Circle geometry, rider number 4. And here we go again. If you see my previous riders, a reminder back again from Circle Geometry Strategies at that address in the same series. And a summary of what's in that video. When doing geometric riders or proofs, know your theorems. I mean, that goes without saying, really. Don't wait for the geometry to come to you. You have to ask yourself questions. As you'll see I do, start with what you're finding or proving. Don't fill in everything you can see equal on the diagram. That really isn't going to help you much. If proving two angles equal, take one and find what it's equal to or what it combines with. If proving something about lines or shapes, ask whatever it is so. If I have to prove lines parallel, say, well, what if the lines were parallel? Oh, these alternate angles would be equal. If you try to prove a cyclic quad, what if it was so? Oh, well, this exterior angle would have to equal this interior opposite angle. So, rider number 4. We have tangents from a common point. Now, remind you of the theorem. It's not going to be used here, but tangents from a common point are equal. There we have PR parallel to BT, and we're given X there. First part, name 4 other angles equal to X. Well, we have the parallel lines, we have tangent, chord, and alternate segment theorems. So here we go. A1 is equal to X, and so is B1 equal to X by tan chord, alternate segment theorem. R1 equals X. R1 equals X, corresponding angles, naming the parallel lines. R4 equals X, alternate angles, parallel lines. Or you could have said vertically opposite, going straight from that X to this X. Next one, prove that PARB is a cyclic quadrilateral. Here we have two options. We have R3 equal to P, which I don't really like, and I'll tell you why I don't like it, is that P is out in the sticks here without equal to anything, so I don't know if that'll work very well. But what I do like here is the fact that we actually have angles in same segment set up that way, and there'd also be one this way. And I like that because I'm sure that I can find something equal there. And in fact, if you have a look, these would have to be the case for this to be a cyclic quad. We have to prove it, and if proving, take one of them and say, what is it equal to? Well, it's already proven. We already have both of these equal to X in the first place. So it's pretty straightforward. So our proof, A1 equals X equals B. Oh, that's the first one, sorry. Yes, there we are, 4.2. R1 equals X, R1 equals X, which equals B1, and it's proven. Therefore, PARB is a cyclic quad, converse, angles in same segment. Notice converse. Notice I never use verbs. I always say that using a verb in geometry is writing an essay. Putting a verb into a reason, why do you do that? Why do we have to say PARB is a cyclic quad? Why don't we just say PARB cyclic? Third part, prove that RB equals RT. So it's about lines, so we say, well, what if it is so? What if RB is equal to RT? Well, then B3 would equal T. Sides opposite equal angles. In other words, isosceles triangle. So let's prove this. We have to prove two angles equal. So once again we say, proving two angles equal, take one, find what it's equal to. What is B3 equal to? Well, there we are. Parallel lines, so therefore the alternate angles, they're equal to one another. R2. Is T equal to R2? Because then we'd be finished. But not yet. I cannot see why T would be equal to R2 yet. So, what else is B3 equal to? And there we are. It would have to be equal to A1 because R2 is equal to A1. So there we are. So we have, is A1 equal to T? And the answer is yes. We've proven it. So we've gone from B3 to R2. Then we've gone from R2 to A1. And we go from A1 to T. So all four along the way are equal. There to equal to that, equal to that, equal to that. So we now have B3 equal to T. So the proof, B3 equals R2. Now all we have to do is follow back in our thought process. B3 equals R2, alternate angles stating the parallel lines. R2 equals A1, angles in the same segment. Remember, we have proven that this is a cyclic quad. A1 equals T, tan chord theorem, alternate segment theorem, or proven. Therefore, B3 equals T. And so we now have RB equaling RT, sides opposite equal angles. Or if you like, isosceles triangle.